Okay. So, yeah. How did you start with the given information? So you have your x is a random variable which is continuous, right?
Yes, ma'am.
It is given you. And your y is equal to x cube. This is what your g of x. Can I say it g of x? Any?
Yes, ma'am.
Okay, it's your g of x. Then, yeah. What was your next step?
Then we will check if it is monotonic in the range of x
Yeah.
which is given or not.
So fx of x is like PDF of x is given to you. That is nothing but 3x square in the range 0 to 1, right?
Yes.
So do you know the nature of x cube in this range 0 to 1?
Increasing, ma'am.
Increasing, right? It's a monotonic function.
Yes.
Okay. So fine. So your g of x is monotonic, and what will be your like support of x?
0 to
0 to
1.
1.
0 to 1 on that interval. It's a monotonic. So you can apply. So is it enough to apply the theorem we studied?
Yes, ma'am.
Okay. So we need one more thing, that's the derivative of x.
G dash x.
Should be
What will be
differentiable
it?
also.
Yeah. Yes.
3x square.
So what is it? Derivative of g of x?
3x square.
3x square.
3x squared. Fine. Okay. Now g inverse of y, theorem was if all the conditions are satisfied, then the PDF of y can be given as 1 upon modulus of g prime of g inverse of y.
So
So what is this g inverse of y? How did you get that?
This is y to the power 1 by 3.
Yeah. So this is nothing but the value of x, right? So your y is x cube, and that is nothing but your g of x. So if I want g inverse of y, then how will it be? Y will be y raised to the power 1 by 3. Is it fine for everyone? Like, any doubt here?
Yes, ma'am. No, ma'am.
Okay. So you have g inverse of y. Just put there what's there. Phi of y.
We have to put in the G dash of X.
G inverse of y. Yeah. So now instead of g inverse of y, I write like y raised to the power 1 by 3, right?
Yes, ma'am.
Modulus into what was it? The PDF, right?
Fx of G inverse of Y.
Fx of y raised to the power 1 by 3. Okay. Then yeah, what was your derivative? It was nothing but 3x square, right? So 3y
Yes,
raised to
ma'am.
the power 1 by 3 the whole square. Is it fine? And fx was 3x square again. Okay.
Yes, ma'am.
1 by 3 square. Yeah. So yeah, it became 1
Yes, ma'am.
for the range. Yeah. What will be the range? This is not for all, right? Fy of y is
This is
equal to
for
1.
0 to 1.
Yeah.
yes.
Then your y will range between 0 to 1. Okay. So your PDF is given as, yeah, 1
1
for,
if y lies between 0
whenever
and
it's
1,
lying between 0 to
otherwise
1,
0.
0 otherwise. Okay. Well, that's it.
Ma'am, third line, ma'am. Last third line.
This one?
Yes, ma'am.
Yeah.
How we get, ma'am? That is,
How did we came here?
yeah,
Okay.
yeah.
See,
Like,
are you okay with this this step? fx of y raised to the power 1 by 3 and g prime
No,
of y.
no, ma'am. First, no, ma'am. F
Okay.
of fx y.
Mhm. Yeah, fy of y.
Yeah,
So just tell me, now your g of x is, which is x cube, is monotonic, right?
yeah, ma'am.
Is monotonic in the interval 0 to
Zero
1.
to yes, ma'am.
Okay. Uh, in Do you know like why we are interested in this interval 0 to 1? Because this is your set of support of x, right? For which your PDF is non-zero, right? That's why we are interested in this range. Okay, your g of x is monotonic in this range,
Yes, ma'am.
and derivative of g prime of x is also you have calculated. It was 3x square. Fine. So
Yes.
now, and your x is a continuous variable. Fine. These are the condition to apply, necessary condition to apply your theorem. So, what your theorem said, if these conditions are satisfied, then if there is any variable, random variable y, which is defined like that, then for that variable, you can define a PDF like that. Fy of y is equal to 1 upon g prime of g inverse of y. This term is in modulus fx of g inverse of y. Fine. Is this fine for you?
Oh, now, ma'am. Now I
That
get.
this is theorem. Okay. So what we did, we just calculate, okay, then what's G inverse Y?
Uh, y to the power by 1/3, ma'am.
Yeah, Y to the power 1 by 3. Okay, that's fine for you.
Yeah, ma'am. I got it, ma'am.
Okay, then fine. Okay. So yeah, the solution is given here also. Okay. So next theorem we studied was if x is your continuous random variable with density function fx of x, and g is any function from defined from R to R, the expected value of g of x is given by integrating g of x, integrating over negative infinity to infinity for the function g of x into fx of x cube. Okay, so here again, uh, like what will be the use of this particular theorem here? They are saying about some function g of x, right? So whenever there is a random variable, yes,
to find the expectation.
to find the expectation of the new random variable y, which is defined as a in terms of function of x. Okay. So yeah. So here is the question which says a passenger train arrives punctually at station every 20 minutes. Each morning, a passenger walks into the train station. Let x denote the amount of time, which is in minutes, the passenger waits for the train from the time he reaches the train station. It is known that the probability density function of x is given in terms of fx of x, which is 1 by 20 for the x lying between 0 to 20. Find the expected value of y is equal to x cube. Okay. Is it understood? Like,
Ma'am, can you show previous slide?
yeah, just a minute.
Thank you, ma'am.
So, do you guys understand the question?
Yes, ma'am.
Okay, fine. Okay, can you please check that link? Now it's working.
Yes, ma'am, it's working right now.
Okay.
Maybe your screen is not visible.
Yeah. Do you need more time for the question?
No, ma'am.
Okay. So, the X was given to you, and its PDF also, fx of X is also given there, which is 1 by 20 for X lying between 0 to 20. Okay, let me just ask one question. That from the given scenario, can you just guess what kind of random variable X is?
It is continuous, ma'am.
It's continuous, that's fine.
Exponential.
Is it exponential? Okay. First, my question is, how did you check whether your X is a continuous or not?
Mom, it's uniform.
Because this is time, ma'am. From 0 minute to 20 minutes. It can be.
Is it the reason? We says X is a continuous random variable if its PDF is continuous. Fine. PDF is given to you. It's continuous on the range 0 to 20. Right?
Yes, ma'am.
Yes, ma'am.
So that should be the reason your X is a continuous random variable. Now the question is you can read the scenario and you have the PDF with you. Can you check what distribution this X is following?
Ma'am, Poisson's distribution.
Distance.
Is it a Poisson? No. They said
Uniform.
Exponential.
Okay. Why are you
Uniform.
saying
And uniform.
Why exponential or Poisson?
It is uniform, ma'am.
Yeah, it's uniform. Why it is uniform then?
Because, ma'am, it is
When
uniformly.
PDF is given like 1 upon B minus A,
B minus A,
20 minus
1
0,
upon
Yeah,
20
ma'am.
minus 0.
1 upon 20.
Okay. But can you like describe it in terms of the question? In terms of the scenario we have given to you? They said train will come in every 20 minutes, right?
Yes, ma'am. So it is
Yeah.
uniform.
Every
And what
20 minutes in. Uh, yeah, ma'am. Uniformly distributed.
and what was your x? X was denoting what? Amount of time passenger waits for the train, right? Amount of time. Yeah, any explanation you can give till then?
No proper explanation, ma'am.
Try it. Like you can try.
Why it is uniform?
Yeah, why it is uniform? That is the question. You have to explain it. So they have given that train will come in every 20 minutes, and x we denoted as amount of time, that too in minute. Okay, in minute, that passenger waits for the train. So let's say the timings of train are 6 a.m., then 6:20, right, and so on, right? Is it fine? In every 20 minutes train will come. Fine. So let's say some person on some random day uh, reached at the station at exactly 7:40. What's its like? What will be the waiting time for this person? 0.
No
If
waiting time.
yeah, 0. That's what 0, right? So your waiting time interval will start from the 0. No waiting time. That's when 0. Let's say some other person reached at 7:42. Then what's the waiting time?
18 minutes.
18 minutes. Okay. Then highest waiting time could be what?
20.
90
Yeah,
minutes.
20 minutes.
20.
20 minutes.
So, is there do you find like it is possible that passenger can reach to the train station at any point of time, right? Between this time
Yes,
span,
ma'am.
this 20-minute time span. So, therefore, this x, which we have denoted as amount of waiting time of the passenger, it follows a uniform distribution for the interval 0, 20. Fine. Is it fine for everyone? Or
Yeah.
any
Yes.
doubt? Okay.
Yes,
Yes,
I'm
ma'am.
fine.
So I explain you this because they may ask you the question with just a scenario. So you should be able to decode that what's your PDF. Once you know that your x is following uniform distribution, now if they do not give fx of x, then you are able to find, right? With this for the same question. Here we have provided you the PDF, but in case if they do not provide and they just give you the scenario, the case, at that time you should be able to find out what's your PDF. Fine. Okay. So now we have to find expected value of y is equal to x cube. So recently we seen that how will you give the expected value of any function? Let's say x cube. Yeah. Anyone?
X cube
X
into,
f of x.
Fx. Okay. Fine. Then
ma'am,
now
in the place of f of x, what we will write? 1
for
upon
which one?
20, no?
Yeah, yeah.
F of x.
This PDF.
Yes, ma'am.
Yeah.
1 by
1
20.
upon 20, no?
Yeah, it will be 1 by 20 for the range x lying between
0 to
0 to
20.
20 and 0 otherwise. So yeah, what will be the integration limits?
0
0
to
to 20.
20.
0 to 20.
So it will be 0 to 20 x cube into 1 by 20 dx. Okay, then
we can take the common out of 1 upon 20. Then in the inner one it becomes x to the power 4 upon 4, and we take the ranges from 0 to 20.
Yeah.
Then we put the upper limit 20 to the power 4 upon
Ma'am, we
4.
get 2000. 2000 in the end.
Yeah. So you can direct, yeah, 20 raised to the power 4 by 20. That's mean this power get cancelled, and you will get 2000 by 4. That is what?
500.
Yeah, 500. So done. This is what your expected value for x cube.
Ma'am, 20 to the power minus 4.
So no, it's
Ma'am,
not a
it should
it's
be
not a minus 4.
2000.
Ma'am,
That is
by
minus.
2000 by 4 means, ma'am, it's not 2000 by 4.
Ma'am, it is just 2000.
Yes, ma'am, it's
Yeah,
not.
ma'am.
Okay. Why?
Ma'am, because
Ma'am,
we
because we
because
cancel
2 to the
120.
power 3 will be 8,000.
We cancel 120.
20
We
cube.
Yeah.
cancel 2 to the power
It should be
cube
8,000.
divided by 4.
Yeah. Okay. Yeah.
Correct.
It's not a 1, it's a 2, like 20 raised to the power 4. Okay, fine. Then. So yeah, here we left with the 20 cube by 4, right?
Yes.
Yes,
Yes,
ma'am.
ma'am.
It is
So 20 cube by 4 is nothing but 8000 by 4, right?
Yeah, ma'am.
Yes.
This will be 8000.
2000.
Yeah, now it will be 2000. Okay. So that is the expected value for x cube. Fine. So the same thing, just integration was there once you decode the question. So there is one more on the same topic. Let x be a continuous random variable with the following PDF, where it's given like that in the interval 0 to 1. Find the value of 2 times expected value of x.
Ma'am, in the place of gx, we have to put x. No?
Yes.
Okay, ma'am.
Ma'am,
Yes,
this function is giving more than one at when we are putting one value.
more than one. What values?
Like at x, if we are putting one,
Mm-hmm.
it should be less than one now. It's fx of x. Or it could be
Yes,
greater than one too.
in this particular function.
Yes, ma'am.
Yeah, it's a 14. Explain. Oh, so,
So it shouldn't be PDF.
yeah. So just check it by just integrating from 0 to 1. Is it giving integral 1 or not?
Okay.
Just integrate the function in the
Ma'am,
interval 0 to 1.
ma'am, I got minus of expectation. Expectation value will minus.
No, expectation can't be negative.
Ma'am, I
I
also get a negative value.
Oh, just check it once again. Is there any calculation mistake or what?
Uh, I got -6, ma'am.
Yes, ma'am.
Okay, let's wait. Did you guys integrate this PDF for the integral 0
Yes,
to 1?
yes, ma'am.
Is it giving 1?
No, ma'am.
No,
No?
ma'am. It's
Response are
giving,
locked.
I think, -3.
Okay, I'll just check. Okay, okay. So there is one correction in the question. Okay. Let's change the question like how it was given to you. 15 fx of x. So yeah, whenever you have a doubt on any this kind of doubts, then first first step you should take is check the whether your PDF is given if it is a continuous random variable. At that time, this integration of your PDF should go to 1. Whatever the range is given to you, like this in this particular
Yes, ma'am.
question, it's not giving you 1. Instead, what's your integration?
15x cube divided by 3 plus
You have to
14.
put the integral limits also.
Yes, ma'am. 0 to
Should
1.
I check here or like what you get? Like when you integrate, just
Minus
give
3.
me this integration. Yeah,
Minus 3.
-3. Okay. Just those who have not checked, just calculate this integration. What it's giving. Yes. Yeah. What is the answer for this particular one?
-3, ma'am.
-3. Fine. Okay. might be 5 here. Now check it. Sorry, not here. Can you just take the integration for this one? 15x square.
Now it's 7.
Okay.
Yes.
Showing 7.
15
Okay.
minutes.
Okay.
Ma'am,
Okay. So
actually,
yeah.
expectation we need to
It's
multiply by into x, right?
Yes.
This
Yes.
expression.
But
ma'am,
the
put it
thing is,
11.
this PDF is not valid. So we have to make this one as a valid, because that's not, we cannot find the expectation of any random variable which do not even, whose PDF even is given wrong. So let's just find if I change, let's say,
Ma'am,
your
k
PDF.
equal to 11 is giving 1. No, ma'am, it's 12. And k is equal to 12.
So yeah, that's what.
11, 11.
See,
11.
let's try it again. If this is your PDF, then what's the value of k for which this should work? Yeah, 11 or 12. Like two options are there for you. Right?
Ma'am, I guess 12.
11.
Ma'am, 11.
It's 11. It's 11.
Okay. Like,
Because
is everyone
it
clear
is given.
how to find this value of k?
Yes, ma'am.
Okay, you have to just integrate it and equate it to 1. So once you integrate it, it just term 15x cubed by 3 plus this x will give you x square by 2, right?
Yes.
2 minus kx. And the limit will be 0 to 1. Integrate to 1. Fine. So
Yes,
for
ma'am,
the,
it's
yeah.
value
What?
of k is 11. 11.
Okay. So this will be, once you put 1 here, it's giving 15 by 3, 14 by 2 minus k. And rest of the part will be 0 once you put it 0, right? Equal to 1. So now, yeah. So k is equal to 15 by 3 plus 14 by 2 minus 1. Yeah. What is this calculation giving to you? So yeah, 15 multiplied by 2 is
11.
30,
12 minus 1.
42 minus 6, right? Is it fine?
Plus 1.
Okay. So k is equal to 11, right?
11,
So,
ma'am.
okay. So now in your question, just make it 11 and just unlocking the screen, you can put your answer there. Now your fx of x is this one, 15x square plus 14x minus 11. And now you need to calculate what is the expected value for the x.
11x square by 2. So 15 by 4.
Excuse me, ma'am.
Yes.
3.
Apart from this doubt, I am really confused with actually the entire week 5. I am not able to find out the cumulative distributive function only of any different function of gx. So can you just help me with how you can find the value of gx cumulative
Yeah.
distribution function?
Yeah, sure.
Just basic. Yeah, basically the mod x1 questions are also very hard. So the week 1 activity 1 question 3, I'm not able to solve only.
Oh, okay. So did you just join now or what?
I joined 5-6 minutes back.
Okay, like today's first question was about the CDF of y only, like CDF of function of
Yes,
continuous
ma'am.
element.
But that's a monotonic function, right? So it's an
Yeah.
easy question. But if it's not a monotonic function, it's very confusing to find out the CDF and PDF. Can you
Okay.
please provide examples about it, about mod and all? It's very confusing.
Yeah, sure.
Ma'am,
So
have you unlocked the response section?
yeah,
The response section is locked.
now, yes, I have unlocked. You have to answer for the twice e to the twice expectation of x. Okay, just let me on the screen. And thanks for the correction. And please note this question, because like next question is also using this PDF. So now our 15 is replaced by 11. Okay, this constant 15.
Ma'am, will you take the example at the end or what? Or
Yeah,
now
sure.
will you?
Yeah, at the end only, because like first of all, I have to follow with the like solve with the session. At the end, I will discuss with you. You want some example to find out the CDF, right?
Yeah, so basically different example for mod and one basic question so that I can understand how to find the CDF.
Okay, okay, sure.
Two examples basically.
Okay,
Thank you, ma'am.
yeah. Okay. So, what's your expected value for this one now?
5.83 something.
Yes, ma'am.
Okay. So, yeah, first let me discuss this one. See, whenever your x was a discrete random variable, how do you use to calculate expected value of the function? Anyone?
X into P of X summation.
Yeah,
Yes,
expectation of x is what?
summation of x of x.
P of
Px.
x. Right? Or summation over all the possible values of x, that is Tx. Fine. So, once your x is a continuous random variable, at that time your expected value is nothing but integral over the whole range, whatever the possibilities are, is x into fx of x dx. Okay. So if they just give you a continuous random, x is a continuous random variable and find its expected value, then you have to go like that. Is it fine? Like, it's not necessary that you always need g of x. G of x will work when we use any random variable y, which is a function of g of x, and you want to calculate expected value of y, then you just replace this x by g of x. Okay. In this particular question, we have asked just expectation of x. So, yeah, expectation of x is what? What will be the integral limits?
0 to 1.
0 to 1. 14x minus 15.
11,
Oh,
ma'am.
sorry, yeah, 11. Okay. So now this is just an integration. So I'm just writing it. If you have any doubt, then just tell me. So it will become x cube, right? So it will be 15 x power 4 by 4 plus this is 14x square. So on integration, it become x cube by 3 minus 11x. Now it becomes x square by 2 and over the limit 0 to 1. So yeah, nothing but the 14, sorry. 15 by 4 plus 14 by 3 minus 11 by 2. Yeah, what's the answer? Final answer?
Ma'am, 35 by 12
Okay.
or 2.91.
But someone told like 5 point something, right? Let's
And we will
check.
multiply to
It's the
Ma'am,
final answer. Final answer.
5.833, ma'am. 5.833, ma'am.
Let's write it in the rational form, no problem, like fractional form. We want 12, right? Is it okay?
yes, ma'am.
Yes, ma'am. It is
So
33 by 12 only then.
like remaining part is just a calculation. So do it fast.
2.91.
Okay.
Now multiply by 2.
What multiplied by 2?
2
Yeah.
times of
Yeah,
expectation.
this is just your expected value, like expected value of x. But we have to calculate twice e of x, right? So this is just 2 multiplied by 2.91. Yeah.
5.833.
Yes, ma'am. 5.83.
Yeah. 5.82 or 83, whatever you write. Okay. So till 3 decimal, 2 decimal or 3 decimal, just take care of that and write according. Fine.
Yes.
So now be careful with your PDF now because in the next one also it's 15 only. So yeah, now in this question just change is that we have a new random variable y which is equal to twice x and we have to calculate variance of y. Will you be able to calculate it? Variance of y?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, give it a try.
Yes, ma'am. Ma'am, this one is a same function, ma'am.
Yeah,
Like previous one.
we have corrected the
Oh,
CDF, right?
11.
Sorry, PDF. Yeah, 11.
Okay.
It's not a valid PDF, so we will go with the valid PDF. So I changed it from 15 to 11.
11.66, ma'am.
Okay. Okay. Do I need to extend the limit, time limit?
No, ma'am.
No, ma'am.
Only 3 responses yet.
I need some time. Huh?
Yeah.
Ma'am,
Yes.
variance could be negative.
No. Okay. So how to proceed with this one? Yeah. So what do we have here? We have a PDF of a continuous function, and we want to calculate variance of y, where y is equal to twice x, right? So variance of y will be look like variance of twice x. Can you further explain it? Variance of twice x.
Remove that
4
2
into
square
variance
root.
of x.
Okay, it's a 2 square variance of x, as you know. So how to deal with the variance of x then? Any possibilities?
Expectation of x square minus expectation of x to the whole square
Expectation
into
of
4
x square
minus expectation of x to the whole square.
Yes, ma'am.
expectation of the x the whole square. Okay. So fine. So you know how to calculate expectation of x and expectation of x square, right?
Yes, ma'am.
So what is expectation of x square then?
Ma'am,
What
integration x square of x minus
integral limits
0 to 1.
0 to 1 x square into fx of x dx, right?
Yes, ma'am.
Okay. So it will be like x square 15 x square minus
Plus
sorry, plus 14x minus 11 dx. Okay. So you might have calculated it. What's like final one? Do I have to write the whole explanation, or should I go directly?
It will be the same answer,
You can go
right?
direct.
Right, ma'am.
Yeah. What's the fraction? Like in fraction, you just tell me what's the fraction you got.
15 by 5.
17.
From 17 by 6.
Yes, ma'am.
17 by 6.
Yes, ma'am.
Okay. And what was our expectation of x that we have already calculated, right? That was 35 by
12.
12.
12. Fine. So just we have to just integrate. So variance of y will be 4 times your expectation of x square minus expectation of x the whole square, right? So it's 4 into 17 by 6 minus 35 by 12 the whole square. Okay. Then what was your final one?
Ma'am, we are getting a negative value, negative 22.6.
Is this integration correct, or should I recheck?
It is correct.
Everyone got the 17 by 6?
Yes, ma'am.
Then how this subtraction can be this subtraction can't be negative, no? So here you will get what? This one integrate power 5 by 15 by 5 plus 14 by 4 minus 11 by 3, right?
Ma'am, it's 17 by 6.
Okay.
Yes, ma'am, it is
So
actually.
I can write it as a 34 by 12. Okay, fine.
Yes, ma'am.
So if it is a 34 by 12 minus 35 by 12, the whole square, then are you getting the negative answer for this?
Yes, ma'am.
Oh,
Yes, ma'am.
That's why I was asking actually.
okay. It should not give you negative one. Like this 35 by 12 was correct. Fine.
Ma'am, can it be possible like
No.
PDF?
Yeah, what PDF?
Like PDF is good, means it is valid PDF and giving negative values. It cannot be possible, ma'am.
No, it's not possible. Okay, so this is kind of calculations. So let me just check for so 40 and 15 as well. It may be possible that as we have changed the PDF, right?
Yes, ma'am.
Using value of k. So maybe the due to that one, we are getting this kind of stuff. But like my point of view is okay, if you know how to deal with the variance of y, that's enough. Since the PDF we have modified the PDF, that's why this kind of stuff like mess up is there. So let it be. We can modify the question, and I will post in the discourse, and also will correct in the PPT when I will share with you. You just do you solve the problem there, and if there is any problem, then let me know. Because variance cannot take the negative value, that's for sure. Okay.
Okay.
So, okay, did you get my point? Like this is creating problem. Why? Because this PDF we changed, right? Because this initially when it was 15, it was not a valid PDF. So we changed it with negative 11. So it may be possible that due to this, it occurred because PDFs come from some random variable, some experiment on which we define a random variable, and then we come up with the distribution. Okay. Here, we just find the k and put that value, and now it's creating problem. So it may be that may be the reason. So this is just a calculation part, but yeah, just take a note that variance cannot be negative. Okay. So okay, let's move to the next question. Here they have solved using this what we say, putting the value x as a 15, sorry, k as a 15. Okay. So the next topic is conditional probability of discrete given continuous. Okay. Do you
Ma'am,
understand the heading?
can you show the previous slide, ma'am, of the solution?
They have used like k as a 15.
And then, what about the expected value, ma'am?
Yeah, expected value also they have used using 15 only.
They have solved
Then
it
we get
like
negative
previous.
in expectation.
But how did they get a positive value?
No,
It
no,
could
no,
be
no.
possible.
See. In this question, here it is 15. Okay. We have changed it to 11. Why? Because this was not a valid PDF. So we changed it and make it K, and we find out that this 15 should not be there, it should be 11. And we solved accordingly. That's why this is not matching. So when I will share the PDF with you, this PPT, at that time I will make correction and will share with you. Okay? Is it fine?
Okay, ma'am.
Okay, ma'am.
Okay. So here, can anyone explain me the heading of this slide? Conditional probability of discrete given continuous.
We have a continuous random variable and we find the conditional probability of discrete.
So yeah, kind of. Like in this this type of question, we will have two random variables defined on an experiment. One random variable will be a continuous random variable and one will be a discrete random variable. Let's say you have two random variable x and y, where x is your discrete random variable. So it's a discrete random variable. So I will talk about PMF, probability mass function. It has PMF as Px of x. And we have given with the conditional densities. That means probability that f taking value y given that x is equal to x has already occurred. So the heading conditional probability of discrete given continuous. So what about this fy given that x is equal to x? This is what conditional probability of continuous given discrete, right? Discrete random variable has occurred and now you are finding the probability for y. So that is given to you, fy given x is equal to x. X is a discrete random variable. So conditional densities and probability mass function is given to you. The conditional probability of x given that y is equal to y naught is defined. Now dealing with the conditional probability of discrete given that continuous random variable has taken some value. Now uh, if y is a continuous random variable, then just tell me what is the probability that y is equal to y naught? Probability that y is equal to y naught?
0.
0. But still it's making sense here. Why?
This is taking around y, man. Why not?
Around y naught, yeah. Because here we talk about around y naught. So that is also one of the reasons that when we elaborate this kind of conditional probability, we explain it as a PMF multiplied by conditional probability y given discrete, y given x at a point y naught divided by marginal of y at a point y naught. Okay.
Ma'am, in this, the y given x is equal to x is given on already, right?
Yeah. Yes. Sometimes given or sometimes we have to calculate.
Okay, ma'am.
But see, it's easy to calculate conditional probability of a continuous given discrete. Okay. Like there will be some
Yes.
hints. Using that you will be able to calculate fy given x is equal to x. So generally the question will be for conditional probability of discrete given the continuous variable. Okay. So should we move to the question?
Yes, ma'am.
Okay.
Yes.
So yeah. A person randomly chooses a battery from a store which has 30 batteries of type A and 70 batteries of type B. Battery life of a type A and type B batteries are exponentially distributed with average life of 3 years and 7 years respectively. If the chosen battery lasts for 5 years, what is the probability that battery is of type A? So, do you understand the question? Like here you
Yes, ma'am.
have batteries of two types.
Ma'am, battery lasts for 5 years means probability of x less than 5, no?
Yeah. So first, from this given situation, you have to find out what, like you have to define your random variables. So then we can talk about x less or equal to 5 or whatever. So whenever the situations are there, this kind of descriptive question is there, you have to first define your random variables.
Ma'am, I have doubt in this topic, ma'am. I can't do questions on this topic.
Okay. If I say you, you have to pick, see, you have this scenario, okay? Now, from this scenario, can you just explain me what's your target? Forget about the random variable. Just find out what's your target. So, there is like 30 batteries of type A and 70 batteries of type B, right? And you are picking one of the battery out of them, right? This is given to
Yes,
you.
ma'am.
Now, you picked up one battery and that battery lasts for 5 years. Like for 5 years, it was like working properly.
Mm.
Then your question
Yes,
is,
ma'am. Working.
when you picked up the battery, you don't know whether you picked up from type A or type B, okay? Because you don't know which one is there. So it worked for 5 years. Now the question is, what's the probability that the battery was of type A? So here, what should be your first random variable?
Picking up of the battery.
Hmm. So
Half.
what kind of random variable it should be?
Uniform.
Is it uniform?
Yes, ma'am. Half half.
Half half. Okay. And anything else? Half half is fine. Is it
But
a half half
Bernard,
probability first?
No, ma'am.
Half
No,
half is
ma'am.
not
Type
fine.
type
No,
A
ma'am.
has
No,
zero
ma'am.
chance.
Point
Zero
three,
point
point
three and
seven.
0.7.
Point three, point seven.
ma'am,
Yeah.
binomial.
Is it a binomial? What we do in
No, ma'am.
binomial? We have n items and we pick some p items, right? That's binomial. So it's not uniform, it's not binomial. Then what?
Bernoulli.
Exponential.
It's Bernoulli.
How are you saying it's exponential? Picking up the battery, right? We the first random variable
Yes,
you
ma'am.
discuss
Bernoulli,
you
ma'am. Success and failure.
yeah,
Yes, ma'am.
Bernoulli.
Bernoulli.
yeah, it's a Bernoulli. Okay, fine. Once it's a Bernoulli, so you will say okay, type A is success or type B is success. That's your choice. Okay, 1 and 0 accordingly you can take. Is it fine for everyone?
Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Now in this particular question, they have asked about the probability that battery is of type A. That means picking up the battery of from type A is your success. That will you will say it as a 1. Okay. Probabilities. I leave over you how to define the probabilities of that Bernoulli random variable. Okay. Then this is your one random variable x. Now here another random variable also has to be defined. What the random variable it will be. So
The average
Life.
one,
battery,
yeah, yes,
average life of the battery.
okay, average life or just a battery life of a fine
Excuse me,
battery life.
ma'am. Sorry.
Yeah,
What will be the probability of the Bernoulli?
you just read the line one. No? I will give time after that also. I'm just helping to find out the random variables. So read the question again, and you will find what's the probability of your success. So
Okay.
just try it once, then we will discuss it again. So yeah, what about the second random variable? Anyone got it? What will be your second random variable? Y
Exponential.
exponential. Is it y is exponential?
Continuous.
No,
It's Y
given,
given.
given. Conditional.
Yeah.
Conditional is
Okay, fine. So now you have x as a random variable, y a random variable which is given over one like condition that is exponential. So you know many of the things. Now you try to solve the question. So now I again restart your time for 3 minutes. For probability of Bernoulli, someone was asking. I will suggest you to read the line number first line.
Okay, ma'am.
Yeah. Okay, are you guys able to solve it?
Yes, ma'am. I guess I have solved.
Because I got only one response till now in the response sheet out of 19.
No, ma'am, it's a bit confusing.
Okay. So should we go hint wise or direct? Should I solve directly?
Ma'am, solve.
Solved, ma'am. Solved.
Okay, fine. So yeah, let's start. So first, your random variable x, which is a Bernoulli. Like, is there any doubt why I am choosing x as a Bernoulli random variable?
No, ma'am.
Okay, it's clear, right? Let's
Yes.
say type A battery was chosen. And 0 for type B. Okay. So first let's calculate. So x is which kind of random variable it is? Sorry, discrete or continuous?
Bernoulli.
Yeah,
Discrete.
Discrete.
Bernoulli. It's a Bernoulli, so it's a discrete. Okay. So once it's a discrete random variable, it will have a PMF, right?
Yes.
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 Okay. What's the PMF that x is taking value 1?
3
0.3.
by 10.
Yeah. So out of 100 batteries, 30 are of type A, right? Is it 30? Yeah.
Yes, ma'am.
So it's 3 by 10.3. Okay. And
Yes,
what with the probability for 0?
7, ma'am.
70
7
by
by 10.
100.
70
Okay.
by 100.
Okay. So it's a 7 by 10. Fine. So now let's discuss about y. Y is what should be the definition of this random variable y? Yeah.
Exponential.
Y given x is equal.
No.
Y
I
given
am.
x equal to.
For example, the definition for random variable x was the type of battery chosen. Okay.
Yeah, battery life of
Life of
the
battery life, sir.
chosen.
Battery
Yeah,
life.
battery life. Okay. Battery life of, let's say, chosen battery, right?
Yes.
Yes, ma'am.
Okay. So, from the question, we know that if we choose a battery which is of type 1, right? This is what I explained in language. This is mathematical. Mathematically, we will read it as battery chosen, like the battery chosen was of type A, then its battery life
Exponential of 3.
is following the
Exponential of 3.
distribution exponential of what?
1 by 3.
1
1
by
by
3.
3.
1 by.
Okay, fine. So, do anyone have a doubt here in this particular step?
No, ma'am.
No,
So,
ma'am.
similarly, y given x is equal to 0 is your exponential distribution with 1 by 7. Is it okay
Yes.
with everyone till now?
Yes.
Okay. Then what should be our next step? If we know, like, I have defined the random variable, then I went for its probability. So again, these are also a random
F of
variable,
y.
right? So let's go for their probabilities.
PDF.
PDF, yeah. So f
F of
y
y.
given x is equal to 1. Yeah. Is what? Yeah, anyone?
1
What
by
will be the PDF for it?
1 by 3 into e to the power minus x by 3
Yeah,
for x
minus x
greater
by
than 0.
But
Should be
why
1.
x is there if we are dealing in y?
Yeah, sorry, y. Sorry, y. For y greater
It will
than 0.
confuse you only, right? Because x
Yes.
is already defined. So y greater than 0. Is
And
it
0
fine?
otherwise. 0 otherwise.
Yeah, 0 otherwise. Okay. And what
Yes.
about fy given x is equal to 0? So this is a PDF of a random variable which is following exponential distribution with lambda is equal to 1 by 7, right? So the
Yes.
distribution for that will be negative y by
Minus y by
7.
7.
Yeah. Yeah. Okay. Otherwise, fine. Is it okay with everyone? If
Yes, ma'am.
anyone has doubt till now, just let me know, because
Ma'am, this
once you are done, yeah,
1/3 and 1/7.
this one, yeah, okay. So in the question you have given that the average lifetime of a battery of type A is 3 years, right? Is it given in the question? Can you read it? Type for time A, sorry,
Okay,
type
okay, okay.
A battery, it's a 3 years.
Okay, okay, got it.
So it's your mean, right? Okay. So once it's a mean, your exponential will be 1 by nu, right? Lambda will be a 1 by nu. Fine. So now we have all the required probabilities, and we want to calculate what was our target. What is the probability that battery chosen is type A? But one thing is given, the value of y is equal to 5 is given, right?
Yes.
Is
And
it
it's
so?
equal to y or greater than and equal to.
Yes, ma'am.
They said it's last for 5 years. More than less than was not used, so I am taking it y is equal to 5. Is it okay? Like in the question,
Yes, ma'am.
we have given that the battery lasts for 5 years. That means the value of y is equal to 5. Okay.
Okay.
Uh, so this is a given condition. So we need to calculate what's
Ma'am,
the,
in that case, is it utmost?
sorry, what?
But is the limit of y, ma'am? It's greater than equal to 0 or strictly greater than 0?
Sorry, what? What you are saying? Where?
Ma'am, in the function.
Here. It should be greater than what you said?
Ma'am, but is the limit of y? It's greater than
Greater
equal.
or equal to, right? Exponential distribution, it is.
Okay, ma'am.
Okay. So,
Ma'am, y is equal to 5.
yeah, y is equal to 5 is given. Yeah.
I mean, in the question, it is framed as if it is utmost, or is
If
it
it
equal to?
was at most, it's equal to. So the question is, if the chosen battery lasts for 5 years, what is the probability that battery is of type A? So is it at most or equal?
It's equal to.
It's equal to,
Equal
because
to,
we,
ma'am.
It's 5
yeah.
years.
So okay. So how mathematically should I write that that last line? It's asking for battery lasts for 5 years. What is the probability that battery is of type A? So what's the given condition and what do you want to find?
We have to
Probably
find
x is
probability
equal
x
to
equal
1
to 1
given
given
y
y
equal to
equal to
5.
5.
Yeah. So may I write it like this, f x
Ma'am, just
given?
one thing want to clarify.
Yeah.
Ma'am, for the this exponential PDF, you have
Mhm.
written y greater than equal to 0. Should it be strictly greater than 0?
Okay. So if we put y is equal to 0, will it give us a 0 as an answer? Like
No, ma'am,
No.
it will give 1 by 3.
it will give 1 by 7 or 1 by 3, right?
Yeah.
So that's why it should be greater or equal to 0.
Okay, but earlier we have already always used on strictly greater than, so that's why I just asked.
Yeah. So that is also a point, like generally in exponential, uh, yeah, it's greater than 0. Why it is so, do you know why it is strictly greater than 0? Because see, in this particular kind of question, or generally exponential distribution will look like this, this type of definition only. At in that case, I will remove this one. Why? Any logic behind that? I should not write this also. Why? Because
because it cannot take negative values.
negative values, right? It's a battery life condition, so it will not take negative values. And one more thing, if battery life is 0, then there is no probability, right? So it should be
Yes.
defined like this precisely. Okay. Thanks for the
Okay, ma'am.
correction. Yeah. So yeah. So this is our question, right? Mathematical format of the question. Is it fine
Yes.
or any correction needed?
No, ma'am, it's fine.
Okay.
It's fine.
So we will go with the formula only. What it says. See, x is
Probability of
our discrete random variable. So we will say,
yes.
okay, random px of 1 into conditional
Fy given
that x is taking value 1, right?
of
Yes.
5.
At a point 5 divided by fy at 5. Okay. So do we have this information? Y given x is equal to 1. So px of 1
Yes.
we
And
have.
we can
Okay. What is px of 1? It's
3 by
3 by
10.
10.
3 by 10.
What about fy x is equal to 1? So just scroll down. Yeah, this one, right?
Substitute.
Yes.
Okay. So 1 by 3 e to the power minus y by 3.
Minus 5 by 3.
Okay. What about marginal PDF of y at a
Add
point 5?
sum of, you have to sum.
Yeah. So if we want marginal PMF of any random variable y, for which there is a given condition on a, like what we say, discrete random variable, then while counting this kind of marginal, we always sum up over all the x belonging to tx such that f y given x is equal to taking value x. Okay, that's what the marginal PMF, marginal PDF of a y. Okay, so and just note the domain at the same time, that y is equal to 5 should belong to this both two, right? So it's belonging there, so we will just add it. Okay, so y by 3 plus 1 by 7 e to the power minus y by 7. Okay, so this y is given to us, so why are we writing y there, right?
Yes.
That's 5 here.
And will it not be multiplied by 10? 1
uh,
by 10, 1 by 30.
what
Will it not be multiplied by 3 by 10 and 7 by 10? The
uh,
below one part.
no. Yeah, it should be. Should it be? Just check it.
Yes.
No, ma'am. I
1
just
by 3,
know.
5 by 7.
Yes,
See,
ma'am.
it should multiply. Yeah. Yeah. Sorry. Because this is a conditional probability, so we have to uh, multiply it with px of x. Do you know why it is so? Because once you like elaborate this thing, it will give you a joint probability divided by marginal of x, right? Once you open this
Yeah.
conditional
Yes.
conditional PDF, it will be joint PDF upon marginal. So just to balance it, we have to multiply it with the marginal. This is
That's
also one of
basically Bayes'
the,
theorem.
yeah, basic. This is one of the like way to remember all to avoid this kind of mistakes. Yeah. So here for this particular y1, what's the probability that it's taking y is equal to 1? So it's a 3 by 10, right? And for this particular,
Yes.
it's a 7 by 10. Fine.
Yes, ma'am.
And
Okay.
can you please give us the summary for this question?
Sorry. Yeah, I will do. So
Summary.
yeah, just a minute. So once you solve it, what will be left with? E to the power minus 5 by 3 divided by, here it will get cancelled, 7 get cancelled, is 3. This 10 also will get cancelled, right?
Yes, ma'am. Only the
So
e power
you
will.
will be remaining with, yeah, e to the power. This should be a minus,
minus
right?
5x.
Yes, 7. Okay. So any further modification we can arrange these powers, right? And we will
Yes, ma'am,
be
but answer is in this format.
okay. Is there an option in this form? No, there is no option in this format, huh?
Ma'am, e to the power of minus 20 by 21.
Minus will be there.
Minus e to the power minus 20 by 21.
So negative is there. Is it so?
No, ma'am. Option.
It's just like what will you do? What will be the steps? So just tell me that. We will
So
deal like that.
basically, we have to take e raised to minus 5 by 3 common, so that we'll
Okay.
get cancel out and we'll get 1
Okay.
upon like that.
So let's say you comment it out. So what will remain inside minus 5 by 3? Here it will be 1. And what will be here?
That we have to calculate.
Yeah. So will you?
Yes, ma'am. One second.
That's the part I should leave on you, right?
Yes.
Yes, ma'am. One second.
Okay.
It's 20 by 21. E to the power 20 by 21.
Okay. How did you get to know? It's okay. General mathematics.
Yes.
Okay. So on a safer side, I am just explaining how to get this. This will get cancelled and you will be like 1 upon 1 plus e to the power 20 by 21. So, okay, you have e to the power minus 5 by 7. This term you had, right? Now you are common, you are taking out common what? E to the power minus 5 by 3, right? You want to take out this term. So whenever the situation is like that, you just multiply and divide whatever you want to take common, okay? So once you are here, you just common out your e to the power minus 5 by 3. Then you are left with what? E to the power minus 5 by 7 divided by e to the power minus 5 by 3, right? Are you getting it?
Yes, ma'am.
Okay. So now you know how to do it. Like this is nothing but e to the power minus 5 by 3 is common. That's fine. This is what? E to the power minus 5 by 7. This minus will go up and will be like minus 5 by 3. Now you know the sum here, right? And that will lead you 20 by 27. Okay? Is it fine with everyone?
Yeah, ma'am.
Yes, ma'am. It's
Okay.
Yes, ma'am.
So yeah, to recall the question. So we have in a store there was 30 batteries of type A and 70 batteries of type B, and their lifespan was given. For battery of type A, the lifespan was 3 years, and for battery of type B, the lifespan was 7 years. But we have given a condition that we have chosen a battery randomly, and we got to know that that battery lasts for 5 years. That means not 3, not 7. Now you have to calculate which type of battery you have chosen. Precisely, they are asking about what's the probability that you have chosen battery of type A. Okay. So for that, we define two random variable. One random variable is picking up the battery. So that was our Bernoulli random variable, where one was our success, that is you have chosen battery of type A. 0 is failure, you chose the battery of type B. Then we calculate the probability as given in the question, okay? Then we define the random variable y as which is denoting battery life of a chosen battery, and the lifespan was given to us, and also given that it was exponentially distributed. So we came up with the situation that if type A battery was chosen, then its lifespan will follow the exponential distribution with lambda is equal to 1 by 3. So we know we got to know about the PDF values of lifespans, right?
And we have given a value
Yeah,
of lambda
yeah.
1 upon 3 and 1 upon 7.
1 upon 3 and 1 upon 7. Actually, we have given with the average lifetime. That means mean was given to you. Once
Expectation,
mean
yes,
is
ma'am.
given to you, your lambda is nothing but 1 by nu. Okay. So
Yes, ma'am.
we wrote the distribution for both of the cases, that what will be the lifespan given that you have chosen type A battery and type B battery. So these were their distributions. Now the question was that the selected battery lasts for 5 years, then what is the probability that you chose the battery that was of type A? So x is equal to 1, given y is equal to 5, right? Because y is denoting your time, x is denoting probability of choosing a battery of type A or type B. So then we went for the formula for this one. So again, look at this. This is our PDF, right? Yeah, sorry, PMF. Now, if you explain, write it mathematically, this is nothing but joint PMF divided by marginal. So marginal will get cancelled, and you will left with the joint PMF of x and y divided by marginal, right? So you just put all these values and you came with the answer that okay, the probability that you chose battery of type A, given that your battery was last for 5 years, is this one. So from this, if I ask you, if I add one more question here, that what is the probability that battery lasts for 5 years, then what is the probability that chosen battery was of type B?
1 minus this.
Yeah. So it will be a 1 minus of this. Is it fine for everyone? Why it is 1 minus? Because your x. So this kind of probabilities fx given y is equal to 5 is a conditional probability of discrete given continuous. So these discrete random variables can have finite values. Like in this particular case, we have only two values, 1 and 0. So once you add fx of fx given y is equal to 5 at 1 and fx given y is equal to 5 at 0, this sum should be 1, right?
1. Yes.
So from here also you can get to know that this is a random, these are the random variables. Okay, so any doubt in this particular session? Any doubt?
No, ma'am.
No,
Ma'am,
ma'am.
Yeah.
I asked about the PDF CDF thing.
Yeah, I will take that. Okay, anyone?
Ma'am, where you uploaded this file, ma'am?
I will upload in this student portal.
Student. Okay, ma'am.
Yeah. So this was all about today's Solve with Us session. So I hope you got some concepts here. And for that question, for that particular question where we change the value of k, I will edit it and send you. You guys try to solve it. If you have any problem, then we are going to meet in the next session. So we will discuss there. Okay.
Okay, ma'am.
Okay, ma'am.
Ma'am,
Next
can you
session will
please
be
give
the
the link?
open session for week 6 now.
Yeah, please repeat what? Please speak one by one. I am not able to listen to both of you at a time. Yeah.
Ma'am, can you please give me the link where you upload these documents?
You have your student ID, right? You open your
Yeah, ma'am.
student portals. There only. In there, you just go for the supplementary content.
Okay. I understand. Okay, thank you.
Okay. Yeah.
Ma'am, next session will be the open session for week 6 now.
Yes, open session of week 6.
Okay, ma'am.
Okay. So those who have any doubt, you stay connected.
Ma'am, next session is office hours, right?
Sorry,
Next session is office hours.
that's by TA, right?
Yes, yes.
Yeah,
Is it
I am talking about the instructor sessions. So that will be on Sunday, it seems, right? It's a Sunday evening, open session, week 6. So, okay, those who have any doubts, stay connected. We will
Ma'am,
discuss that. Yeah.
why are the TA sessions not being recorded?
Uh, TA sessions are not for the recording purpose. That's why. Like
But in
it's just a question answer session kind of things, right?
yes, ma'am. But every time, many students, including me, cannot attend the TA sessions because of some other reasons. So if it is recorded, it's better we can watch it later on YouTube.
Oh,
If we have also same doubts, so we can also get to know what's the answers and all. So
okay,
can it be
okay.
recorded?
I will talk about the support team regarding the same, and we'll talk to you later. Okay,
Yes,
so
ma'am.
those who have any doubts, stay connected. Those who do not want, they can leave. Okay. Thank you for the session today.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thanks.